I'm here with Stefania and Martin from the Databricks team. If you both would love to give an introduction, that'd be awesome.
Yeah, hi, my name is Stefania. I'm a product manager here at Databricks, working at the intersection of Unity Catalog and the Databricks runtime, basically making sure that data governance is enforced at runtime.
I'm Martin. I'm a software engineer at Databricks, and I work as well, but from an engineering side, on the intersection between runtime and data governance. How do we build the APIs that make it possible to protect all of the data, how to bring this to our clusters, and how to make it seamless for our customers.
That's awesome. And for those that don't know me, I'm Josue. I'm an architect at Kythera Labs, which helps empower health and life sciences organizations. I'm also an advisor to Sunny Data, which does Databricks servicing, and a few other organizations as well. So for today, we are going to be talking about some of the security mechanisms that Databricks has in place to help safeguard your information. One of those is LakeGuard. So tell us, Stefania or Martin, what is LakeGuard?
With Unity Catalog, we brought data governance to the lakehouse, right? Customers are able to secure their data lake using fine-grained access control, so that they can ensure like all their sensitive data is always protected. They can enforce data privacy, they're compliant, and all of that. So with Unity Catalog, we changed the model how governance is done. Now governance follows the user, so I have certain permissions, and before in Databricks, governance followed the cluster, where a certain cluster could access whatever data it was kind of configured with a credential. So our job with LakeGuard was pretty much ensure that data governance is always enforced at runtime, following the user's permission model. So it's basically, how does Spark enforce data governance? And if we look at Spark, I mean, it's 10 years old, or no, a little more even. It wasn't really built with governance in place. It's a single JVM. There is no decoupling of like the Spark engine and the application. So it was intended for single user applications. The cluster was kind of like the isolation boundaries. But we now want to run the lakehouse on shared compute with like everyone having their own permissions, and we want to have this fully enforced. So we had to do some work in order to make sure we can always enforce governance. And that's basically LakeGuard. So like all our clusters are powered by LakeGuard, and they ensure that governance is enforced at runtime.
What types of compute does it actually impact?
It impacts all of the UC compute in Databricks. So it's the shared cluster, the single user cluster, also Databricks SQL. And what we actually did, especially like on the shared cluster, is in order to share compute, we need to make sure all user code runs in full isolation. So if I write my Python UDF, like it shouldn't kind of go read Martin's data. So we need to, from a systems perspective, make sure my user code can't kind of break out, it needs to be isolated. So we did a little surgery to Spark and also built a couple of isolation primitives, so that basically the application no longer runs like on the engine. So we now have Spark Connect in between, which basically decouples the client from the server. So with that, we built kind of like one isolation layer. Then every client on a multi-user cluster runs in its own isolated container. And then all the user code you develop in terms of like UDFs that run on the Spark executors, they're also fully isolated so that we can break out of that. So as a result, we have like a full multi-user compute with full data governance in Scala, Python, and SQL.
What does it mean for shared compute, SQL serverless compute, and serverless? What does all that mean, really?
So if we look at, SQL compute, like SQL as a language was always, much simpler than, like I would say Python and Scala. It's not a general purpose programming language. It was meant for data access, which meant that in many data warehousing systems, SQL databases were always considered to be, secure to a degree. And, like with UC, we have these kind of like governance rules. So in SQL serverless, it's already, the governance is like built into the system because it's a very limited surface. However, customers were asking for extensibility in SQL. So we started to provide them with, Python UDFs for DB SQL and generally governed Python UDFs. And they as well run fully isolated using the same kind of lake guard primitives that Stefania already talked about. Now, when we go into talking about serverless generic compute or serverless notebooks and jobs or serverless Spark is a more, I would say easier pattern. It's much harder because the surface that our users and customers are using Spark is much broader. But the good thing is the same kind of architecture that we're using for shared clusters is the same architecture for serverless. We want to make it as easy as possible to move in between these different types of compute so that you as a user don't really have to worry about this. So fundamentally is that for all of these compute types, shared clusters, SQL Serverless, and serverless notebooks, jobs, this kind of lake guard technology is completely built in. It uses the same kind of underlying architecture and makes it easy to move between the individual pieces.
I'm using serverless compute. Should I be really worried about the confidentiality of my data in terms of what Databricks is doing on the back end to safeguard my my PII?
No, of course not. I mean, obviously, we care about our customers' value, and this fundamentally means that our number one job is to protect the customer's data. And we protect it with all of the compliance regimes that we have to fulfill as a company to even offer you any kind of service that is in the realm of serverless compute. So running serverless doesn't mean you sign off all of your rights to the data and then all of a sudden it's gone. We have to fulfill all of the compliance regimes for encryption at rest, and encryption in transit and all these kind of things, to make it happen. However, this is just one piece of the infrastructure layer. There's a lot of, rules and governance primitives on top of that you apply essentially as the customer, as a user, using Unity Catalog to secure your data. So in Unity Catalog, you then have the ability to say, I want to, partition my data to different groups. I want to assign grants to different groups and so on. And this is essentially where you have the most control about how your data is used. So generally, we see the most concern not about Databricks doing something with data, but really it's within the organization. It's within essentially the groups that access the data. How do I make sure that my sales team doesn't see, somebody else's data? How do I make sure that if I have email addresses, social security numbers, that these are correctly, protected? And I think this is really where the lake guard technology empowers our users to run this kind of, fine-grained access control that operate at the lowest possible granularity, or the finest possible granularity.
Can you give me an example of how lake guard works with PII?
So it's a great question. So the way that I look at this is, in Unity Catalog, as I already mentioned, we have different levels of, kind of permissions. At the highest level, very coarse granular, there's tables and schemas. But that's, very, very coarse. The next level below would be, for example, views. Views give you access to a subset of the data that allows you to join data and bring this and shape this essentially into the form that you needed. One level below that is actually what we call row level security and column level masking, which then allows you to apply specific transformations directly at the table level to these tables to say, I want to mask out all of the social security number digits. I want to mask out email addresses and so on. And why is this so important? Because nobody likes data duplication. Nobody wants to copy data around just to protect it. So you really want to enforce these kind of, primitives at this level. However, since to be able to apply these masking rules, the engine needs access to all of the data, you need a secure and trusted environment that now processes this data in a secure enclosure, so to say. And the customer, the user code, my UDFs, or my notebook code never really touches the engine. So there's kind of an air-gapped, to use these kind of weird terms, an air-gapped environment between my user code and the engine, so that there's never an exchange between the actual raw data. And this is really what lake guard provides from a technology perspective.
What is the benefit to your customers in using either the shared compute, SQL Serverless, or serverless?
If you're running, let's say, Python or Scala, I think there, our recommendation, if you want to be on classic, is use shared clusters, or use, if you're serverless, use serverless, of course. The recommendation is to use shared clusters because what we've built with lake guard made us the industry first and only Spark platform or governed lakehouse that can actually enforce fine-grained access control on multi-user compute. With Databricks, you can run like multiple Scala workloads in a secure setup on multi-user compute. And that's also what works behind the scenes for serverless. And that's because of like all the kind of technology, which is completely abstracted away from the user that we had put in place. So this ultimately helps you maximize utilization because you can share compute. It will help you bring down your TCO while still running on a fully secure lakehouse. You can share compute between multiple users and multiple workloads. So with that, you get better utilization. You also don't have the operational burden of having like many clusters up and running. So it's like all of those aspects that help you better manage your environment.
How does LakeGuard and really Databricks in general handle data governance across different departments, such as isolating access between finance, HR, and other teams while still maintaining operational efficiency?
Yeah, I think that's in fact very inherent to like what Unity Catalog offers as a governance solution. So enterprises can set up their data access permissions to model whatever kind of structure they have in the enterprise and granting access to those to data to those teams that need access using all the fine-grained access control mechanisms that Martin had mentioned, such as masking data, masking PII data, and so on. Once this is in place, they use UC Compute, and we just make sure that all of that is enforced. So there's no like extra overhead here. And given that compute can be shared also cross departments, there's never a point in time where data is at risk.
For companies managing diverse data types, including ML models and unstructured data, what are the implications of LakeGuard's governance capabilities, particularly around data privacy?
We have to split this probably into like a little bit of a couple of answers in this because it's a very well encompassing question. So the number one part is that, like Unity Catalog is great for storing all kinds of data. It's not just, the traditional relational data that we're seeing, like from CSV files or Parquet files or Delta or whatsoever. But it's as well, we have, Unity Catalog provides primitives, for all kinds of data using volumes. You can store unstructured data, and then you have governance on these data types as well. So you don't need to worry about like, as soon as I leave the Brave table world, all of a sudden stuff gets complicated or weird. No, governance is really everywhere. However, there's one particular part that is kind of important to mention is that there are certain workloads that, due to their nature, require a much more low-level access to the Spark engine. Like in particular, machine learning is part of that. Like when you run model training, when you're using GPUs, that's really like down to the lowest level of like tweaking the last little bit of performance out of a Spark cluster. And these kind of systems don't really work well on shared clusters. And for that reason, we have the way to bring the LakeGuard technology and the LakeGuard features as well to single user clusters by essentially, we are offloading this computation, we're offloading the enforcement of row level, column level security of views to an external, data processing service that then only brings back the data to the cluster that requires this kind of additional protection to really make sure that for all workloads, all data types, all file types, we're always enforcing, the data governance regimes. And the best part about this is that we made this completely transparent. As a user, if you're using a Databricks runtime, a new one, like you just query the table and it works. You don't need to configure anything. There's no knobs. It's like 100% simple.
How does LakeGuard help mitigate potential data breaches or inadvertent data exposure on shared Spark clusters, and what fallback mechanisms are in place for if the isolation fails?
We need to take a step back here and look at the different layers of security. Like a former teacher of mine always said, like, hey, security is like an onion. It's like there are all these kind of different layers, and it's like defense in depth. And essentially, LakeGuard is one of those layers. It's the lowest layer that we have that provides this kind of like infrastructural security to all of our compute types. However, on top of that, our users and customers are modeling their own security layers on top of that. They're modeling their own access permissions, their data, masking permission, all of this. So in all it becomes essentially the protective net for protecting data breaches, for protecting, inadvertent exposure. And when we're talking data breaches, it's not just, like to outside, actors, but as well within the company. It's like incidentally, sharing data between teams is not as uncommon as we might think it is. Well, so it is really important to make sure, like, are we set up for success? For example, a great example is instead of granting permissions to individual users, grant permissions to groups, because people move around within organizations. So their grants shouldn't necessarily follow an individual's permissions, but they should follow their role. So using groups as a mechanism to detach grants from individuals and attaching them to a group is a much better mechanism to make sure that certain exposure doesn't really happen in the first place. And I think that's why I would really say it's all a combination of things. It's a combination of us as Databricks providing, a secure engine that we provide that allow you to run custom code fully isolated, but as well all of the governance and compliance, policies that the customers apply on top of that to follow their own kind of like security models.
That's a lot of business and technical jargon. What now? I'm in an organization. So what do I do now? What should I do, if anything at all?
Yeah, they should establish their lakehouse where governance follows the user and not the cluster. So like use all these very powerful features from Unity Catalog, move your clusters, move your workloads to shared clusters, where you get multi-user compute. You can bring your costs down. You will have reduced operational burden. And it's a very easy migration to serverless.
Thank you both so very much for your time. I truly appreciate it. And I hope for the people watching this that it was very, very helpful.